All right, guys, so now we are going to be on lecture 6.4. All right, we are 6.4, equation involving inverse trigonometric functions. So what is the strategy? First of all, it's about isolating one of the inverse functions, and second, take the corresponding trig function of both sides, isolate the variable. All right, so I'll let you read the process, and I'm going to start by work on the practice number 1, where we have y equal 4 tangent 3x 4x. So we need to solve 4x. So obviously, first of all, I'm going to divide by 4 both sides, and if I divide by 4 both sides, I end up to have y divided by 4 equal tangent of the angle 3x. I want to solve for x. I want to make sure that you do understand 3x is the angle, but 3x is the angle. But what I want to solve is not for the angle 3x. I want to solve for the variable x. Okay? So what I want to do first is use my inverse function, both sides. So I'm going to have tangent minus 1 of y divided by 4 equal tangent of negative 1 of tangent of the angle 3x. Okay? Therefore, I end up to have a tangent to the negative 1, y divided by 4, equal 3x. And it's pretty easy now to divide by 3 both sides and end up to have x equal 1/3 of the inverse function tangent minus to the negative 1 of y divided by 4. It is as simple than that. So, let's try to solve 3 arctangent of x equal pi. First of all, I'm going to divide by 3 both sides to have arctangent of the angle x equal pi over 3. Then, I'm going to multiply by tangent because arctangent is tangent to the negative 1. So if I multiply both sides by tangent, if I take the tangent both sides of the arctangent of the angle x equal tangent of the angle pi over 3. And therefore, that implies that x equal tangent pi over 3. And what is the angle that gives you, so what is the value of x? And it's going to be very easy because that is going to be sinus pi over 3 divided by cosinus pi over 3. Looking at your trigonometric circle, you end up to have square root of 3 divided by 2 over 1 over 2, and you end up to have x equal square root of 3. Okay, so if you compare with previously we decided to take the inverse, tangent to the negative 1 both sides. On this one, we took tangent. Okay? Why? Because when we're having tangent of tangent to minus 1 of x, arctangent of x, it becomes x. It becomes x. Third problem. So, on this third problem, we have sec to the negative 1 of x equal cosec to the negative 1 of x. So I'm going to take the sec both sides. If I take the sec both sides, I end up to have sec of sec to the negative 1 of x, and I know that is going to be equal to x equal the sec of cosec to the negative 1 of x. So, what do we have? We end up to have x equal the sec of cosec, and let's pretend that on this left side, x equal 2. This is just, okay, let's pretend, I repeat, let's pretend that x equal 2. What do we have? It's sec of cosec to negative 1 of 2. So, how do we find x with sec of cosec to the negative 1? Well, first of all, when we are writing sec of cosec to the negative 1 of 2, this is defined as an angle theta. We having the sec of the angle theta, and theta is equal to what? Well, theta is equal to the cosec to -1 of 2. Remember, I decided to write x equal to. Just to change, I just decided to change my problem right here. I decided to have x equal to right there, okay? So when you have theta equal cosec to -1 equal 2, that implies that the cosec, this time of the angle theta, equal the cosec of cosec to the -1 of 2, and that means cosec of the angle theta equal to 2 over 1. Why do I say 2 over 1? Because I know that cosec, because I know that cosec of the angle theta equal 1 over sinus of the angle theta, which is the hypotenuse divided by the opposite side. Therefore, if my cosec of the angle theta equal 2 over 1, that means the hypotenuse equal 2 and the opposite side equal 1. So if I decide to draw a right triangle and I define an angle theta right here, my hypotenuse equal to 2, my opposite side equal to 1. Therefore, if I want to find the adjacent side, let's call that a square plus 1 square equal 2 square. So a square equal 2 square minus 1 square, which is a square equal 4 minus 1, which is 3. And so a equal square root of 3. It cannot be negative square root of 3. We're having a triangle. So when I decide to express cosec theta equal 2 over 1, I can easily pretend that x, lowercase x, I'd like to remind you this is what we are looking for, lowercase x equals sec of the angle theta. And I decided to say that sec theta equal 1 over cosinus of the angle theta. And I know that cosinus of the angle theta equal adjacent side divided by hypotenuse. But I just calculated my adjacent side. I know it's square root of 3 and my hypotenuse is equal to 2. So when I'm going to calculate x, which is sec of the angle theta, which is 1 over the cosinus of the angle, it's going to be 1 over square root of 3 divided by 2, which is going to be 2 over square root of 3 because I flip my fraction when it's on the denominator, when I convert my main fraction into a multiplication. And if I want to rationalize this denominator, I will have 2 square root of 3 divided by 3. Okay? All right, guys, let's jump to the next problem. You can rewatch this video, take your time. I can guarantee you it's not that complicated. It's just a question of get used to manipulate, but we are almost at the end of the semester, and you will see that at this point, you should be able to move faster. All right, so in this problem number 4, every time you are going to see arc sinus, arc cosinus, you are going to start to freak out. And you should not freak out because you're always trying to do the same thing. And the first thing you want to do is isolate one of the trig function. Okay, you are going to try to isolate one of the trig functions. So let's try to isolate arc cosinus, arc, and then cosinus of the angle x equal pi plus arc sinus of the angle x. I'm going to take the cosinus both sides. Our cosinus is the old-fashioned way for cosinus to the -1. So the same thing that we've done previously when we multiply by tangent both sides when we were dealing with arctangent, we're going to do the same thing by multiplying by the cosinus. I'm going to take some green right here, and I'm going to write cosinus of arc cosinus of the angle x equal cosinus of the angle pi plus arc sinus of the angle x. Okay? Now, actually, let me do in green. All right. So, what are we going to do? We are going to use the angle addition formula. Okay? So, we are going to use the angle addition formula. Remember, we're having arc sinus plus pi. So on the left side, cosinus arc cosinus x, that will be equal to x. It's not a big deal. Right here, let me do that. Right here, we are going to end up to have x. Let me write that in blue. And on the other side, we are going to have cosinus of the angle pi times the cosinus of the arc sinus of x minus the sinus of the angle pi sinus of the arc sinus of the angle x. You can see right away that right here, this is going to be equal to x, okay? Sinus of arc sinus x, that's equal to x. Sinus pi, well, sinus pi equals 0, right? This is equal to 0. Okay, so that means now we're having x equal cosinus pi equal what? Cosinus pi equal -1. So just to remember, cosinus pi equal -1. So we end up to have -1 multiplied by the cosinus of arc sinus of x minus 0 times x. 0 times x is equal to 0. So we end up to have x equal negative cosinus arc sinus of x. What do we do now? Well, remember, when you are writing right here, cosinus of arc sinus of x is playing the role of an angle. So we can totally write x equal negative cosinus of the angle theta. So if I look at the angle theta now, theta equal arc sinus of x. Okay? So if I take the sinus both sides, if I decide to take the sinus both sides, let me write some space like this. I can take the sinus both sides. I think you should be okay now. I take the sinus both sides, sinus theta right here, and a sinus of arc sinus. I can totally realize that the sinus of the angle theta equal to x. Okay? Equal to x. By the way, x over 1. And I know that the sinus of my angle theta is equal to the opposite side divided by the hypotenuse. So what do we have? We're having a triangle. We're having a triangle with an angle theta. We know that the hypotenuse equal 1. We know that the opposite side is equal to x. And we don't know the adjacent side. So to calculate the adjacent side, I'm going to use the Pythagorean theorem. I end up to have a equals square root of 1 minus x squared. And why do I need this adjacent side? Because I'm looking for calculating the cosinus of my angle theta. And I know that the cosinus is equal to negative because of the negative right here. So we have still negative, adjacent side over hypotenuse. And because my adjacent side equal 1 square root of 1 minus x squared over 1, I end up to have x equal negative 1 minus square root of 1 minus x squared. So therefore now we're having x equal negative square root of 1 minus x squared. I'll let you solve this equation. I will ask you a question via Edpuzzle to see if you find the same answer. It's pretty easy solving this equation, and you will have a part 2 for this